Good afternoon, everybody. Happy Friday, and welcome to this afternoon's webinar. Thank you very much for taking the time to join me. I'm Stephen Burt. I'll give you a little bit more information on who I am shortly. So we've got the usual format for the webinar this afternoon. There's probably a little bit more content in this one than there might usually be. So I expect we might be perhaps 45 or 50 minutes or thereabouts. So if you have any questions which come up as we progress through the webinar, you should be able to see in your control panel a little questions box. So type them in as we go, and I'll do my very best to leave 10 or 15 minutes towards the end where hopefully I'll be able to provide you with some answers. So we're going to look today at PAS 2080. This is the specification, the publicly available specification for carbon management in buildings and infrastructure. We'll think about some of the deadlines around it, the National Highways deadline, which has been set for some of their contractors towards the end of this year. So yeah, we'll just crack on. So a little bit of an introduction to NQA first. So NQA are a global certification and verification body. We offer all the usual ISO standard certifications and verifications. We are a UCAS accredited verification and certification body, if that means anything to you. UCAS, the United Kingdom Accreditation Service, they accredit and govern certification bodies like NQA to be able to deliver the services that we do. The services that we provide are, in third party, entirely impartial, entirely objective certifications and verifications. So there's just a little list there in the orange box of some of the standards and specifications which we provide services for, and you can see many of those are greenhouse gas and carbon and sustainability type standards. But the one we're interested in today is PAS 2080. So as I mentioned, I'm Stephen Burt. I'm NQA's Carbon and Sustainability Services Director. I've been, it makes me feel old, over 25 years experience in carbon, energy and environmental management, but I've been with NQA for 15 years. I'm also a lead carbon or greenhouse gas verifier myself for all of the main carbon standards, including PAS 2080 and some other wider sustainability standards as well. So that's just a little bit of background to myself. I've got quite extensive construction industry experience as well, which is obviously relevant to what we're going to be discussing today. So just some of the objectives. We should, by the end of the webinar, have gained an introduction to the PAS 2080 specification itself, the nature of it, the background, the purpose. We will work through some of the requirements of the specification and hopefully cast some light on exactly what's required. We'll talk about value chain member roles. I'll expand on what those are very shortly, because that's a key element of the PAS 2080 specification. And we'll talk about whole life cycle stages and whole life carbon emissions and removals, which is obviously key to PAS 2080 itself. We'll touch upon as well some of the potential reduction or mitigation options around whole life carbon in buildings and infrastructure as well. So quite a lot to pack in. So buckle yourselves in. It's going to be quite a detailed content that we've got for you today. So just a bit of context and introduction first. So PAS 2080, this is what it looks like, the green one, combined with a guidance document, which is the blue one. So these can be obtained easily. If you search for them, you'll be able to find them and download them online. It's titled Carbon Management in Buildings and in Infrastructure. There's a distinction between the two, which I'll cover shortly. It's a 2023 version of the standard that we're working with now. And NQA offer independent third-party verification to PAS 2080. We don't offer accredited, in other words, UCAS accredited verification, because At the minute, UCAS do not offer the capability for us to become accredited. But as with all things at NQA, if we offer unaccredited services, we organise them as if they were accredited. So it's a standard for the management of carbon in buildings and infrastructure. It's focused on the construction value chain. It's really applicable to companies within that value chain. So if, for example, you are architect or a civil engineer or a construction, a demolition company, if you own and operate buildings, or if you're a product and material supplier to the construction industry, then if you haven't heard of PAS 2080 yet, then it might come across your desk fairly soon. And it's all about managing whole life carbon across the full cycle, the life cycle of a building project, from the initial concept stage all the way through to the end of life, the demolition or the dismantling stage of any building. And we're not just talking about buildings here, we're also talking about infrastructure. So infrastructure, really, we're thinking about roads, we're thinking about bridges, power stations, waste, water, waste management sites, pumping stations, all that type of thing falls under the umbrella of infrastructure, and we'll look at that in a little bit more detail shortly. So why is PAS 2080, why was it created? So basically because the UK has a statutory commitment or obligation to reach net zero by 2050, and buildings play a huge part in the UK's carbon emissions, greenhouse gas emissions. So just digging around, you can find out some figures. You know, buildings, in inverted commas there, account for about 39% of the UK's energy-related emissions, with about 28% of that coming from the operation of the buildings, heating, lighting, cooling them, and about 11% from the actual materials that go into the construction and the construction processes themselves. And then because there's a focus currently on highways for PAS 2080, which has been driven by National Highways, the government agency, we should also think about user carbon. So domestic transport also accounts for a huge amount of greenhouse gas emissions in the UK. So combined, the contribution to the UK's greenhouse gas emissions is really quite significant, and that's why there's a need to consider whole life carbon in buildings and infrastructure, and that's why PAS 2080 exists. So it's a publicly available specification. It was developed by BSI with lots of input from a team of internal and external experts in that field itself. It was originally published in 2016, and it was revamped and quite significantly strengthened in 2023. And overall, it provides us with a framework for managing and reducing the carbon emissions associated with the buildings and infrastructure. And as I mentioned, it tackles whole life carbon, from the planning stages, the concept stages, through the design and build, operation and maintenance of the buildings or the infrastructure themselves, right through to the final demolition and dismantling. So for that reason, there's lots of different what's called value chain member roles, which are a part of the whole life carbon planning for any building or piece of infrastructure. So, you know, the designers, the product material suppliers, the asset owners and managers, the constructors, the demolition companies themselves, all have a part to play in reducing and managing that whole life carbon. And that's really the focus of PAS 2080. It's about collaboration, it's about engagement with those different members of the value chain so that everybody's working together to achieve the end goal of decarbonisation in the sector. That's really strongly emphasised throughout the specification, that idea of collaboration, of engagement with each other, with innovation, and challenging the industry status quo, the business as usual elements of construction. So that the emphasis is extremely strong on all of those issues. It's supported by a guidance document. It's not an ISO standard. For those of you who are used to ISO standards with what I consider to be a nice logical flow in the requirements and nice easy indications of what needs to be documented and what doesn't need to be documented, it really doesn't lend itself to that. It's not an ISO standard. It's not really written to ISO standards, although it's a very, very powerful specification for what it sets out to achieve. There is some kind of early discussions around ISO, International Standards Organization, creating ISO standards similar to PAS 2080, which we've seen for some other publicly available specifications. But for the minute, PAS 2080 is the one that we're working with. So it is, as I mentioned, a very powerful very powerful tool in the supply chain, very powerful in achieving what it intends to set out to achieve. It's very effective, and it applies this value chain approach to each member of the value chain. So what do we mean by the value chain? There's four main definitions. The first one is the asset owner and manager. So that could be, for example, local authorities who construct and operate, oversee the construction of housing and public buildings, that type of thing. Could also be developers as well, developing, for example, new housing schemes. It applies to designers. So designers, as you would imagine, are organizations like architects, civil engineers, consulting engineers would fall under that bracket for value chain member roles. The third one is constructors. So don't just think about construction companies here. We should also think about demolition companies, and also civil engineering companies would fall underneath the constructor role. And the fourth main value chain member role is product and material suppliers. So any company which supplies products or materials into the construction process make up that fourth role. So that could be, for example, cement, concrete, asphalt, any aggregates, bricks, all other kind of materials, timber, steel, rebar, anything that goes into the building could be considered a product and material supplier. Because of the really strong focus that it has on collaboration and innovation, there's I call it a snowball effect. So if one member of the value chain, so for example, a constructor, seeks PAS 2080, then the other members in that value chain will begin to feel some pressure being applied to do the same. And that's because of the very strong focus on collaboration and engagement with other members of the value chain. So it really creates this snowball effect in terms of the number of companies that are seeking PAS 2080 currently. So what PAS 2080, the way it's laid out, it sets out requirements firstly for all value chain members, and then it sets out individual requirements for each individual value chain member as well. So if you're reading it and you know what your value chain member role is, read it carefully to make sure that you're clear on exactly what does and what does not apply to you in terms of the requirements of PAS 2080. And of course, some organizations can have one or more value chain member roles. So in highways, for example, often or sometimes the constructors and the designers can be the same organization. Sometimes, occasionally, constructors and product and material suppliers can be the same organization. So just bear that in mind when you're reading it as well, and you're defining what your own value chain member role is. Is it a management system standard, or is it a carbon verification standard? In the world in which I operate, ISO management system standards, there's a clear distinction between those two things. This one, PAS 2080, it's a bit of both, to be honest. It involves a combination of establishing a management system and it involves quantifying carbon, greenhouse gases, and planning to reduce those greenhouse gases. So it's a nice, comfortable mix of the two. And again, that's part of the strength of PAS 2080 overall. So what do we mean by infrastructure? Well, we have, or what does PAS 2080 mean by infrastructure? So within the UK National Infrastructure Plan, the definitions of infrastructure include transport, so that's going to be highways, road bridges, the rail network and so on. Energy, so power generation, power distribution as well through the distribution network. Water, so water supply, wastewater treatment. Waste, so waste management facilities or national infrastructure, and communications, so for example masts, underground fibre cables, all of those would fall under the PAS 2080 requirements for infrastructure. And then separately but related are buildings. So this we can think of as more general building construction and demolition projects, and we can think of that as being kind of slightly distinct and different from the infrastructure aims. Remember, the title of PAS 2080 is Carbon Management in Buildings and Infrastructure. So it's going to be of interest to general construction companies as well as civil engineering companies and all the other members of the value chain which are involved in infrastructure and buildings. And why should you use it? Well, emission reductions often result in cost-saving opportunities through identified reductions in material and energy and labour as well. It provides a really good measure of consistency in the industry and throughout the supply chain. And you know, it helps with risk reduction, it helps with reputational issues, it helps with brand enhancement. It's quite a newish standard. There's not very many kind of companies out there who are PAS 2080 verified yet. So, you know, getting a competitive advantage from that might be a possibility. And when we look later on at the procurement requirements, in other words, the setting up of contracts for PAS 2080 companies and their supplier selections, we'll see that it really helps with meeting tender responses, it helps with managing supply chains, helps with meeting any stakeholder expectations as well. So that's the key to the kind of drivers behind it overall. So let's look at the drivers in a little bit more detail. One of the main ones at the minute is National Highways, which is the organisation that looks after the roads network in England and Wales. And National Highways have publicly stated that they're going to require all of their contractors and their subcontractors to be PAS 2080 certified by 31st of December 2025. And there's also chit-chat that the Environment Agency are going to follow suit, Network Rail, National Grid, the public water companies, perhaps even local authorities are all kind of rumoured to be thinking along the same lines as National Highways. In the private sector, a lot of the big construction companies, some of which are NQA's clients for other ISO management systems, maybe the private water companies and the power generation companies, I expect will begin to think along the lines of PAS 2080 as well. And that collaborative focus means that the supply chain pressures are likely to become a little stronger as time progresses. I've included a really good quote there from one of our PAS 2080 clients. It's no longer about price and program, it's about price, program and PAS. And that was a comment they made when we were discussing their ability to win tenders. So from a competitive point of view and a competitive advantage point of view, that's one of the main drivers for it overall. So let's think next about the background to carbon management in buildings and infrastructure before we move on to look at PAS 2080 requirements themselves. So overall, this diagram's pulled straight from PAS 2080 itself. There's lots of opportunities to reduce whole life carbon emissions in both buildings and in infrastructure when we think about PAS 2080. It sets out this really quite nice diagram to start off with, where, you know, along the green boxes we've got the whole life cycle of any building project, all the way from the initial concept, the initial strategy, right through to the end of life activity as well. And what it's trying to show is that the ability to influence the whole life cycle carbon of any building or piece of infrastructure is at its highest at the very, very early stages. And the ability to influence reduces over time as the building becomes to reach end of life. And at the same time, the accuracy of the carbon or the greenhouse gas assessments is at its lowest at the start of the process and at its highest at the end. And the reason that's important is because there's a continual improvement feedback loop in PAS 2080, where we take, or we're intended to take, as-built carbon emissions after the project's finished and feed that back into the start of the next project, setting a new baseline. And in that way, continual improvements achieved, and the accuracy begins to improve, and also the ability to influence. It will remain high at the earliest stages, but it's quite a nice little diagram there, I think so anyway, that just provides an overview of the influence and the accuracy concepts. PAS 2080, we need to think about the life cycle in the construction process. So what it does is it refers us to a couple of other standards, BS 15978 and BS 15804, which are two standards which provide definitions of life cycle stages within the construction process itself. And you as a company are expected to be able to control and influence those life cycle stages which you're involved in. Certainly to control them, you might have influence over more than the ones you're directly involved in through, you know, supplier and contractor appointment. So these standards, really every PAS 2080 system that I've seen uses these definitions, A1 to A3 for the product manufacture side of things, A4 to A5 for the construction stage, B1 to B5 for the use stage, and then C1 to C4 for the end of life stage. So almost, in fact, every PAS 2080 system I've seen uses those definitions to define the life cycle stages that any particular company is interested in. So if you don't, you know, if you're going down the route, I'm sure most of you out there will be involved in the construction industry, I guess, so you might already have copies of those standards and be familiar with this. But those of you that aren't, that's a great starting point, those two standards and the life cycle stages identification and categorization. PAS 2080 works to a hierarchy. The hierarchy in the 2023 version is about avoid, switch, and improve. And it focuses in on capital carbon, operational carbon, and user carbon are the three different definitions of the whole life carbon within that hierarchy itself. So capital carbon, straightforward enough, that's the emissions associated with the creation and the end of life treatment of the asset, the building or the infrastructure. And we have options. We can build nothing, so for example, sweat the asset, in other words, extend its life, for example, a road or a building. Avoid any demand for new space, so offices, for example. Think about the designing and the planning side of towns and cities. We can build less as well. We can maintain our existing assets adequately, refurbish existing buildings, apply circular economy principles. I'll talk more about that very shortly. And even things like, you know, design for ease of dismantling the buildings would all come under the capital carbon heading. As would the ability to use alternative materials. So for example, these are, when I've done PAS 2080 verifications, the use of low carbon alternative materials. So for example, GGBS cement, fly ash containing concrete, biofuels, HVO, which is hydrotreated vegetable oil rather than using diesel, using recycled and reprocessed materials in the first place, like asphalt and aggregate, low temperature asphalts, alternative material containing asphalts, using recycled steel, rebar, even carbon absorbing paints I've seen used in projects that are being managed under PAS 2080. So we can build clever as well within the capital carbon category, and then build efficiently. So coordinate and work with other utility services, for example, when accessing buried services, to make sure that there's no unnecessary wastage in terms of materials and time and energy. So that really comes under the capital carbon side of things. The operational carbon and the user carbon aspects of the PAS 2080 within the hierarchy of avoid, switch and improve. Obviously the operational carbon for a building would be the energy consumed during its life cycle. And we can think about the design for cooling and heating and lighting and building energy management systems and so on at that stage. On roads, we can think about efficient lighting design. There was a great example in Sweden of a several 100-kilometer long electric highway that they'd built that charges your electric car as you drive along it. And there's also, in terms of minimizing user carbon, things like rolling resistance, maintenance of road surfaces, electrification of the railways. So there's lots of different examples of whole life carbon considerations in buildings and infrastructure. So moving on to PAS 2080 itself and thinking about some of the requirements around it. So as I mentioned earlier, it's important to recognize that the requirements within the specification are organized as being applicable to all value chain members and or individual value chain members. So first step to do is identify your value chain member roles so that you know exactly which requirements apply to you. So not all the requirements apply to every company, and we must base the application of the PAS 2080 specification on our specific role. It's organized across 12 clauses overall. And then there's 3 very useful annexes at the back, Annex A, B, and C. Some of the headings here, for example, Clause 1, Scope, Clause 2, Normative References, Clause 3, Terms and Definitions, Leadership, Continual Improvement. These are all terms that you'll be familiar with potentially from other ISO standards if you're involved in them. So let's have a quick look at the actual requirements of each clause themselves. So Scope 1 is around, Clause 1 is around scope and just covers the intended outcome and the boundaries. Clause 2 is about the normative references, which are mandatory references which you must use, but there aren't any in this document. And then Clause 3 gives us terms and definitions. Now that is an important clause because the terminology that's used isn't everyday terminology. Reading and understanding the terminology clause is, in my opinion, an important thing to do so that you know exactly what it is that PAS 2080 requirements are asking you to conform to. Clause 4 is the decarbonisation principles. So it's quite a lengthy clause, this one. It's focused upon, it is high level principles. The actual detail of how to implement those principles is actually provided in subsequent clauses. But it covers thinking about the control and influence that any one company has over each life cycle stage of the construction project in terms of managing whole life carbon. It covers trying to align the whole project from start to finish with net zero ambitions. It covers the application of the carbon reduction hierarchy that we mentioned, the avoid, switch, and then improve hierarchy that's core to PAS 2080. And it also covers the governance requirements, the governance aspects of the carbon management system. So it's laying out in quite a bit of detail actually, but still quite a fairly high level, what the decarbonisation principles of the specification itself is. And you'll probably find when you read clause 4, you'll find that most of the requirements are expanded upon and duplicated to some extent within subsequent clauses. Clause 5 is about leadership. So this is exactly what it suggests, setting out the leadership requirements for PAS 2080. There's requirements in this clause for policy for carbon management, a strategy for carbon management, things we would usually expect, like providing or making sure the resources are provided, including resources in terms of people, making sure that roles and responsibilities are defined, making sure that communication channels are established, making sure that there's collaboration being led by the leadership throughout the value chain, and also making sure that the individuals involved are trained and they're competent as well. So this is the kind of typical contents that you might find in a carbon management policy and carbon management strategy. These are kind of typical headings that you would find. 9 times out of 10, this is a document, of course, and it lays out the policy and the strategy for the business in terms of carbon management. And that would be more or less the kind of typical contents that you might find within that particular document itself. In terms of training, this would perhaps be how you might identify what the typical training arrangements might be. So, general PAS 2080 awareness training for maybe all staff or maybe suppliers and subcontractors. There's going to be people, boots on the ground, whose job it is to do the data collection at site. So maybe the site managers, the procurement teams might require, activity data collection for carbon conversion or for conversion into carbon. There's always going to be some form of carbon quantification tool, and we'll look at one of those in a second. Individuals in the bid teams and procurement teams, quantity surveyors, maybe if carbon leads are appointed, we'd need to have training in how to use those carbon quantification tools. Typically for designers, and quantity surveyors, they have professional body training through their own professional bodies and CPD requirements, which often cover the requirements around carbon. So that might be a training requirement is in there as well. The senior leadership team might require training in carbon strategy, and even perhaps, the marketing team might require some kind of training in carbon communication. So that's just to give you an idea of the roles that may require different levels of training for PAS 2080 purposes. Clause 6 is about integrating the carbon management into decision making. In other words, making carbon management something that's at the very core of the business. Whenever a decision is made, we're considering carbon management on an equal footing along with, quality management or cost or that type of thing. So it's really getting carbon management into the core decision-making process. And PAS 2080 provides us with a reasonably useful diagram to try to emphasize that the clause 6 requirement, integrating carbon into decision making, lies at the very center of the overall carbon management process itself. There's a nice table at the back of PAS 2080, table B1, that summarizes the different carbon management process requirements at each work stage, and it does that for all value chain members, and that's working through the life cycle of the building and cross-reference in each stage to the clauses within PAS 2080. So if you're writing, which you would have to do, a carbon management process for PAS 2080 purposes, table B1 is a good starting point to identify how you might want to go about doing that. There's some good information on roles and responsibilities at each stage as well. These are RACI diagrams, responsible, accountable, consulted, informed diagrams. You won't find those in PAS 2080 itself, but you'll find those in the guidance document for PAS 2080. And they're really useful in laying out who, or rather which, value chain member is responsible at each stage of the life cycle process for the different aspects around carbon management, and it helps you to identify which areas you can control, which areas you can influence, and it also sets out who, or which value chain members rather, are accountable, who needs to be consulted, and who needs to be informed. So that's in the guidance document. I find it very useful. If you take the time to read it, you might find it to be useful as well. And then the carbon management process itself. So this, in my experience, are the kinds of typical arrangements that we would encounter. So overall, there's a carbon management governance process set by the strategy and the leadership in the organization. And then often there's a standalone carbon management policy. Sometimes that's integrated with existing environmental or sustainability policies in a business. Usually there's a carbon management strategy document of some kind, which is aimed obviously at implementing the policy requirements, and then a documented, doesn't have to be documented, but usually almost always is, carbon management process, which really is the process or the procedures that are needed to make sure that when contracts are undertaken, that they're managed in keeping with the requirements of PAS 2080. So from the process, the carbon management process, we're usually setting up the project specification. We are quantifying and identifying and undertaking the carbon assessment itself. So actually putting together numbers in terms of carbon against each of the activities, and in turn that allows us to identify low carbon options and low carbon opportunities that can be presented as part of a dual bid. So often there's a dual bid takes place in PAS 2080. If a construction company is asked to bid for a particular role, they will, for a particular project, sorry, they will quantify the baseline carbon, baseline being what would happen if we didn't try to integrate any whole life carbon reduction opportunities, and the cost of that will be presented with the carbon data alongside a dual bid, which is the low carbon option, with the costs associated with that and the carbon data, and the two bids go to the customer or the intended customer, and then the customer can choose which ones they wish to do. Surprisingly, in my experience, every time I've seen this take place, the customer has chosen the more expensive but lower carbon bid, and that's one of the key strengths of PAS 2080. It drives that decision making, going back to clause 6, where we're trying to make whole life carbon at the core of the business decision making processes, and that helps with the competitive advantage side of things as well, of course. Project design obviously feeds into the data collection and the baseline setting, as does the procurement process side of things. So, the appointment of material suppliers, the appointment of subcontractors, all feeds into that baseline setting process, the targeting for reduction process, and the dual bid process. And we then have the project build itself, and then once the build's complete, there's a process of pulling together as-built data, the as-built carbon data, that is, and then that can be compared to what the original baseline was, what would have happened without the intervention of the whole life carbon management. And then once the as-built data, carbon data is collected, that enables the whole life carbon assessment reporting side of things to take place. And often, or sometimes rather, there's a requirement to report back to the customer and perhaps the relevant agency as well. So, for example, for national highways projects, as the national highways projects are undertaken, there's a requirement to send carbon data to the highways agency, national highways, and keep them up to date with the progress as it goes. And all of that combined should lead to continual improvement, potentially with an audit and review cycle where that as-built data and the outcome reporting all feeds back into the strategy, and then the process starts all over again. So that, in a very simplified nutshell, is what the carbon management process for PAS 2080 might look like. You know, I'm sure there's many different ways of doing it, but typically these are the kind of arrangements that I would see in place. Clause 7 is the actual carbon assessment process itself. So the whole life carbon assessment principles to support decision making. PAS 2080 does not, you know, the specification itself does not tell you how to quantify carbon. Instead, it points you to other methodologies. So it tells you that the greenhouse gas quantification process should be derived from existing life cycle assessment standards or other recognised sources. It highlights BS 15978, which we've discussed already, the Sustainability of Construction Work Standards, and typically that would apply to asset owners and managers and construction companies. BS 17472 is about the sustainability assessment of civil engineering works, so calculation methods. Typically that would apply to designers and constructors. And then one we haven't mentioned is BS 15804, which is the environmental product declaration rules. So the product material suppliers would ideally, in an ideal world, provide a EPD or an environmental product declaration with the cubic meter of concrete that they supply you, or the ton of steel rebar that they supply you would come with an EPD, which would tell you what the tonnage of carbon dioxide equivalent, the embodied carbon in those materials would be. Life would be very easy if that happened in every circumstance, because the carbon calculations would be nice and easy to do. But if you're a product material supplier, almost certainly somebody at some time has asked you for an EPD or an environmental product declaration. So those are the three main British standards which can help with the greenhouse gas assessment process. There's also other sources, of course, which can be wholly or partly used. So we've mentioned EPDs already. The UK government carbon conversion factors are a superb, comprehensive, fantastic source. National highways themselves have their own carbon tool, as does Transport Infrastructure Ireland for the Republic of Ireland, have a similar carbon tool, and they do the hard work for you. They're one of them's an app, one of them's a kind of Excel-based document, spreadsheet rather, which you plug some numbers into one end of it, for example, how much cement you're going to use and what type it is, and out the other end comes the carbon data. And then you can play around with them, and you can actually change the type of material that you're using, and you can identify low carbon opportunities by using, for example, GGBS cement or fly ash containing concrete or HVO or biofuel or whatever it might be. And you can play around with those tools and they'll do the hard work for you in terms of the greenhouse gas assessment process. Clearly, those tools are intended for highways projects. You know, Transport Infrastructure Ireland and National Highways are primarily highways infrastructure organisations. So, but they're useful not just for highways projects, for any construction projects. Actually, you know, it's possible to use them for those as well. It might not cover every angle, but a good starting point for learning how to do it. There's also the ICE, the ICE database, the Institute for Chartered Engineers, and the RICS databases. The Royal Institute of Chartered Surveyors have something. There's a built environment carbon database, and then there's ISO standards, PAS standards, a different one, and the greenhouse gas protocol. All of these things can help with the greenhouse gas assessment process itself. If you are interested and you haven't seen it already, that's where you can get the National Highways Carbon Tool. It's dead easy. You can download it for free. They have e-learning, a free e-learning training program on the same website, and guidance documents on how to use it as well. And the TII, the Transport Infrastructure Ireland Carbon Tool, is similar, but you have to ask them to be able to access it. So I've got access to that one. It's equally as useful, but you can't just go online and download it. You need to ask them for access to it and sort of justify why you need it. But remember, those are for National Highways projects. But if you want to get a good overview of how the carbon assessment, or rather the greenhouse gas assessment process works, those would be really good starts. Good place to start. Clause 8 is about target setting and baseline. So this is establishing what the baseline is in any project. So baseline is defined in PAS 2080 as the scenario for what carbon emissions and removals would have been in the absence of planned measures aimed at reducing them. And these graphs are just examples of the outputs of this process, where you know, certain materials are being specified, the associated carbon is being calculated, and then alternative low carbon materials which do the same thing are being specified, and lower carbon figures are being produced as a result as well. So the graphs on the left there will show you kind of typical construction project carbon calculation. The graph on the right shows you, different techniques for laying, for example, HDPE pipe in road. If you use the open cut technique, there's the carbon emissions. If you use the no dig technique, there's the carbon emissions. So this is all part of the dual bid process, where you can go to your customer and say, you can have this at this cost, there's the carbon, or you can have this alternative low carbon one at this cost instead. And that's what PAS 2080 is all about at the end of the day. Just thinking about some of the mitigation arrangements for whole life carbon as well. We see there's some really good options these days. The HVO, which is a low carbon fuel, you can see immediately there that diesel has a carbon conversion factor of 2.51. HVO has a carbon conversion factor of 0.036. So, much less carbon from using HVO. It's slightly more expensive. Something similar for biodiesel there as well, and much lower, usually a little bit more expensive as well, and needs mixed in with existing diesel. But from a site operation point of view, plant generators, welfare cabins, all that kind of thing, changing out from diesel to HVO can see a really significant carbon reduction. There's also low carbon materials. So for example, some cements out there compared to traditional Portland cement might be 10 to 70% lower in terms of the embodied carbon in it. Likewise, using recycled rather than virgin materials for aggregates and components within asphalt and concrete and these types of things. And there's some quite clever but still a little bit niche technologies out there which can actually work to remove, to sequester carbon dioxide straight from the atmosphere as the construction process takes place. So lots of examples there. In terms of carbon sequestration, there's paints, which I don't know too much about, but I've certainly seen them in use. I don't know the data behind them to any great extent, but there are paints out there which you can paint hoardings with and that type of thing, which will absorb carbon dioxide. And then design activities, types of paints that are used, passive design. Circular economy principles. So I saw a fantastic example of a building, 2 buildings actually being demolished and being replaced by one new one, and third sector organisations were invited to come into the 2 old buildings first and choose what they wanted in terms of fixtures and fittings from those buildings. And then the construction company that were involved removed the radiators, the boilers, the light fittings, the carpets, the all the different staircases, even all the fixtures and fittings were removed and put out into a lay-down area. And then third sector charitable organisations were able to come along and uplift them and take them away for reuse, rather than just seeing them going into a skip and going to waste. And those circular economy principles are also a key part of the whole life carbon and reducing carbon. On-site energy generation for cabins and site offices and plant and things. Obviously, it's quite common these days to see solar panels at construction sites, sometimes with battery storage. I've even seen hydrogen fired welfare units with hydrogen fuel cells, but also with hydrogen boilers that provide heat and electricity to the cabins. And of course, you can procure 100% renewable electricity supplies to sites if they're permanent and long-term ones. So I'm going to put the foot down a little bit because I'm running out of time. Clause 9 is about monitoring and reporting. Straightforward enough. This is about gathering the KPI information, the key performance indicator information that's needed to monitor the carbon as the project progresses, and that's the actual carbon, the as-built carbon, so to build a picture of that, and then to put all that into reports of some form and provide them to other values of the other members of the value chain, so that they can see the whole life carbon in action as the project progresses, and we can get an as-built carbon figure from doing that activity. Clause 10 is about procurement. It's quite a lengthy clause, but it's critical to the PAS 2080 process. So it lays out quite specifically, really in black and white, about what the contractual terms should be encouraged to be, what the contract award should be encouraged to be, how we should source suppliers, how we should engage suppliers, and how we should collaborate with suppliers to encourage the reduction of whole life carbon. And this is the main clause where that snowball effect begins to take place. As soon as one company has got PAS 2080 verification from an organisation like us, then their procurement processes kick into action, and part of the supplier evaluation becomes about carbon and whole life carbon and their ability to deliver low carbon solutions. So it's a very, very strong clause within the standard that encourages supply chain collaboration and value chain collaboration. And clause 11 is a continual improvement clause. So that's, we saw the little diagram earlier on where, we capture the as-built carbon data of the project once it's up and running, and then we feed that data back into the next project, into the baseline setting for the next project that takes place. And over time, that continual improvement loop leads all the way back to one of the first slides I showed you, with that nice little graph with I think it was an orange line and a blue line or something, where we looked at the accuracy of the carbon data. increasing as the project life cycle develops, and the ability to control and influence decreasing as the the life cycle project commences. So that little continual improvement loops make sure that the quality of the data that's been fed back to the start of the processes increases over time, and therefore each project gets better and better in terms of decarbonisation, one after the other, over the course. And then the last clause is about claims of conformity. So we have three options. We sit as NQA at the top of that, the options, both in terms of order, but also in terms of how robust and credible the claim is. So we offer independent third party. It's actually verification to PAS 2080. So we're a third party external verification body. We can come in and completely impartially assess your system, your carbon system, for conformance to PAS 2080, and then award a certificate which states exactly what's involved and recognises your efforts and meets your customer demands as well by doing that. There are two other options as well. Other party validation, they call it, so that might be getting a consultant in to help you with it, and self-validation is the kind of lowest option. That's marking your own homework and validating yourself as being PAS 2080 conforming. So just to summarize those key learnings then, hopefully we've got a bit of a better understanding about the fundamental principles and concepts of carbon management in buildings and infrastructure. We've got a quick, brief overview of the structure, content and purpose of PAS 2080, and hopefully we can see and understand how it helps to support decarbonisation and net zero ambitions overall. So if you need any further assistance from us, we can help you in a number of ways. On our website, we've got some PAS 2080 case studies with companies that we've worked with. We run these webinars reasonably frequently, the PAS 2080 ones, as well as on lots of other topics around carbon management. We have an associate partner program, which if you need a consultant to help you, we can put you in touch with 3 trusted consultants that we work with, and they can help you with the consultancy side of things. And of course, you can always contact me. You can find me on LinkedIn and things if you wanted to contact me that way. Courses wise, we've got lots of different courses. The one that you may be of interest to you is that there's a 2-day PAS 2080 course, which might be of interest to some of you if you wanted to get more detailed and slower speaking information, because I've been talking very fast as we've gone. And any further support, NQA's website. And thank you very much. I've left us 3 minutes. Apologies for that. There's a lot to cover in there. If anybody's got any questions and wants to put them in, I'll be happy to answer them any now. Pippa's asked, can we share the slides and presentation? Yes, I think NQA training send out the recording and the slides after that. So I'll ask my colleague to do that. And Yuri, thank you very much for the comments. Anybody else, any questions at this stage? Doesn't look like it. Good. So we've got that done in an hour after all. I thought I was going to be talking for the whole afternoon at that point. All right. Well, listen, thank you very much indeed for taking the time to join me. As I say, feel free to get in touch and I'll be happy to advise you on how we might be able to help you or anything else PAS 2080 related. Thanks very much, folks. Have a great weekend. Thank you. Bye-bye.